The previous video show you the application, the operational management of the scrapers. For this one, we focus on how to estimate the production of scrapers. So, like I say in the previous video, the scraper used to excavate whole or dumping material over a medium to a long haul distance. And we have different type of scrapers as you see in the previous video. And now let's move to the productions. How can we determine the production of the scraper? Scraper production, and one of the time of scrapers show you in the finger here. To determine scraper production, same as the loader dozer that we did in lesson 3 and the first part of this lesson, we can be able to determine with the find out the fixed cycle time, travel time, and then payload, etc., and then the efficiency factor. So all of that will be applied in scraper productions. So let me wrote down a few notes where those information can be obtained. The first one is fixed cycle time. It can be get it from table 4.7, and during the next application in the problem, the next problem 2, I will show that. And then how to determine the travel time. For travel time, we can use either, depends on the information given for the problem, you can use of the travel time curve, travel, or we can use the average speed method, something we did before. We have the distance, we have the average speed, we can divide, we get the travel time. So it's average speed method. And one thing that we need to determine, if you recall, that is volume per cycle in the productions. How can we determine in scraper? It's important that is basically we have to determine the payload per cycle or volume per cycle. As we say earlier, it have to be a function of minimum of the rated weight payload, rated, so that something given and the heap volume capacity, heap. So get the minimum of, find out 2 and get the minimum of that before we apply in the equation to determine production capacity, heap volume capacity. So with that, I want to emphasize the payload per cycle. We need to determine 2 things: rated weight payload and heap volume capacity. What is heap? That go to the bucket volume we discussed in lesson 2. And now I apply that to the next problem so that easy for us to see what's going on in rated weight payload and heap volume capacity. What are the difference between these two? And something we say, use the travel time curve. Basically, this is the travel time curve for 2 scenarios. The first is when the scraper loaded, and the other one is when it empty, return to the original excavation area and load the material to them. And use different curve for different scenarios as I mentioned. So that applies to problem 2. And estimate production of a Caterpillar wheel tractor scraper 361G single engine to Axle Tractor. What is that about? Go to the previous video, we have all of that. Hose travel time curve are shown in the following figures. So those are the travel time curve for two scenarios with loaded and empty. And the maximum hip volume, 34 LCY, maximum payload, 81,600, material common earth, and then they give you the density for loose cubic yard and per band cubic yard. Rolling resistance, job efficiency, operational condition, average single pusher, that is whether we put the tractor to push, and then the whole route, we have 5 sections. Level loading area, level is mean the slope is 0. Downhill, 3% grade, that is the slope grade, 3%. The distance, 2,000 feet. Level dumping area, so no slope. Up, 3% grade, so positive slope grade. And then level turnaround, it means 0 slope grade. So all of that, how can we do with this problem? The first thing first, we need to find out the volume per cycle. And in this case, keep that in mind. We need to find out the payload per cycle minimum of those two. We need to find out those two first. So the first one is the weight of the hip capacity. We need to determine for this one, what is the weight of hip capacity. So weight is equal to hip volume, 34, time the density, in this case 2,480 LCY per pound per LCY times 34 LCY. So you will get those two. You will get 84,320 pounds. So that is the weight. And then, as you can see, the payload, maximum payload. So in this case, you have the hip volume capacity and weight load. They give us to you and have to get the minimum. So maximum payload 8160. So it get the small one. So as you can see here, the weight, this one is greater than that right down. That right down here, the minimum. So we can have the payload per cycle. Payload per cycle. It have to be equal to the minimum up to. The first is the rated weight payload, that is 81,600 pounds. And then the hip volume capacity, 84,320,000 pounds. So from that, we can have that it equal to 81,600 pounds. And we find out in volume per cycle. So you will divide by the density, 2,480 pounds per LCY. So from that, cancel out, we get the LCY. So and it get 32.9 LCY per cycle. So that is the first thing we need to find out, is the volume per cycle. And then to find out the travel time, we need to find out the effective rate, and that go to lesson 3. So the effective rate. And 4 different scenarios we need to find out. The first one is the hole, which is section 2. So you have the first one in the hole sections. So it means section 2. So you have the down 3%, so it will be negative 3% slope, plus rolling resistance 100 pound per ton divided by 20, something we do in lesson 3. So from that we can get plus 2%. So that is the effective rate for the whole section 2. And then we can also have the return, which is section 4, and it go up 3%. So we have plus 3%. The rolling resistance remain unchanged, 100 divided by 20. So you will have that is plus 8% effective rate. For loading areas, section 1, it will be a fixed cycles. We use that one. And then level dumping areas, they don't give you a distance. So basically that is also a fixed time. So we only need the turnaround time for section 5. So it will have the turnaround. And that is section 5. And for that one, it level here. So you will have it 0% plus 100 divided by 20. So you will have plus 5%. From that, we can use the chart for travel time. When that we have travel time, U chart. For section 1 or section 2, which is whole, and that you will chart number 1. So let me write down here. You can have this here chart number 1, and this is chart number 2. And as you can see, this one is during the whole, so it have a loaded. So you have chart 1. Chart number 1. What do we get? Effective rate 2%. Effective rate 2%. And the distance is 2000. So you can have that one is 2000 here. Go to there to meet the 2%. And going down, so that is the time, and it will be about 105 minutes. 105 minutes. From there, we have 105 minutes. And then for section 4, which is empty. So we use chart number 2. What do we get? And also 2000 feet. So this one here, 2000, and go to 8%, slope 8%, and take out here. So that it will be 1.45 minutes approximate from the graph. So 1.45 minutes. And then turn around, section 5. And by now I think you can know what chart we use for turnaround. It already empty. Go back, load again. So it will use chart number 2. Number 2, because turn around to get loaded again. So that chart number 2, and the slope is 5%, and the turnaround is 500 feet. So we have that one here, 500 feet at 5%, so somewhere in between 4 and 6. So it will be around 0.4 minutes. 0.4 minutes. So you do 0.4 minutes. So of course from that we can have the travel time. Add them up, we get 2.9 minutes. And then the next one we need to find out is the fixed cycle. The fixed cycle, and that table 47. What are the things we need to put down in the fixed cycle? To have this, the first fixed cycle, it will be spot. Bring the scraper into the spot and then load the material, and then maneuver and dump the material. So maneuver and dump. So those are the fixed cycle, and we need to find out that from table 47. Let's go to that, GC 7. And what is the operation condition? Go back here. If you recall, it will be the operation condition is average. Material common earth. So all of that we can apply here. From that we can spot, average, and single pusher. So you have 0.3 minutes for the spot. For load time, average, single pusher, 0.6 minutes. Maneuver and dump time, average, single engine, 0.7 minutes. So those are the fixed cycle time. So we just put in from the that table. So we have that one is 0.3 minutes. And then we have 0.3 minutes, 0.6 minutes as we mentioned, and this one it will be 0.7 minutes. So from that we can have the fixed cycle time or fixed time to be short. It will be 1.6 minutes at all of them. 0.3 plus 0.6, 0.7. So we have the total cycle time equal to travel time plus fixed cycle time. So it will be fixed 0.6 minutes plus 2.9 minutes for travel time. So you get 450 minutes. And when you have that, you can apply for the productions estimated. Productions, and that should be equal to load per cycle 32.9, and we already find out 32.9 LCY per cycle, time number of cycles, so it equal to 60 minutes per hour divided by cycle time, 4.50 minutes. Time efficiency factor 50 minutes per 60 minutes per hour. So from that we can production equal to 366 LCY per hour, and that's the answer for the production of scrapers in these scenarios.